Hello and welcome to this tech talk on the business case for cloud computing. I'm your host, Galen Pyle, from the Portland office of Slalom Consulting. I specialize in advanced infrastructure services. I'm a cloud systems administrator, and I'm going to tell you a little bit about the cloud as well as a deep dive into Amazon Web Services. This tech talk is designed for business and salespeople as well as should be engaging to techies. So let's jump right in. The first question that I'd like to ask is, what is the cloud? Some people say it's magic, but here I like to go around and ask people, what do you think the cloud is? What does the cloud mean to you? Because the cloud is actually a metaphor, right, of the clouds, compute power being in the clouds. And so it's a little bit of a philosophical term in some sense. So let's jump right in. I have a definition right here. So I think the cloud is three things. I think it's a service through the internet, meaning that you can access the cloud through a web browser. But the application software and user data is stored somewhere remotely, and you don't know where the data is stored. Okay? So that's kind of the metaphor. Plus, cloud services are sold through the utility business model. The utility analogy. So when you try to get electricity in your apartment, you plug into an electrical grid managed by experts to get a low-cost, reliable power supply available to you with much greater efficiency than you could generate on your own. So electricity is a utility service available to you on demand, and you pay only for what you use. Cloud computing is also a utility service, giving you access to technology resources managed by experts and available on demand. Access to these services are over the internet, right? And the data is stored remotely with no upfront cost to you, and you pay only for the resources that you use. That's the idea. So I'd like to give you a very brief introduction in the history of cloud computing. In 1961, a computer scientist named John McCarthy at an MIT lecture proposed that computation may someday be organized as a public utility. And so this is seen as the first public announcement about the idea of cloud computing. It took 38 years later when Salesforce.com pioneered the idea of delivering enterprise applications via a simple website. And that's a software as a service. We'll talk more about that. In 2006, Amazon Web Services was the first widely accessible cloud computing infrastructure service. So I want to talk about the three main categories of cloud computing. So first, there's also a distinction between the private cloud and the public cloud. The private cloud is built using your own resources in your own data center, whereas the public cloud, which I feel like is more common, is hosted by a cloud vendor, and the infrastructure is shared between organizations. So when we think of the cloud, we usually think about the public cloud. Software as a service, simply put, is e-commerce service over the internet. And most people who've used the internet have used some software as a service. For example, Gmail, Facebook, Amazon.com, Microsoft Office 365, and Salesforce are all softwares as a service. It's like an application that's given to you as a service with that cloud utility business model. Then there's also platform as a service, which is a collaborative platform for software development. It gives you all the tools in order to develop and makes it easier to develop, but you don't have to manage the underlying infrastructure. So examples would be Microsoft Azure, Google App Engine, and I think HostGator, for example, you can use to make websites, and that's a platform as a service as well. Infrastructure as a service is where you rent virtual servers on demand. Two examples being Amazon Web Services and Rackspace. So I want to talk about the categories of cloud computing. In traditional IT, you manage everything from applications all the way down to the operating system, virtualization, servers, and storage. You have a lot that you have to do. You're going to have to hire professional IT people to manage this for you. That takes time, that takes resources, and it's a lot of work. With infrastructure as a service, the vendor, for example, Amazon Web Services, they manage the virtualization, the servers, the storage, and the networking. That's all done by the vendor. So then you just have to worry about patching the operating system, the software that you want to install on the servers, the data, and the applications. For platform as a service, the operating system is also managed by the vendor, whereas you only have to manage the applications and the data. Software as a service, even the applications and the data are managed by the vendor. That's why, for example, with Salesforce, they give you a simple website and they manage the data, they manage patching the services, they manage the underlying servers and virtualization, and you just have to use the software, right? So software as a service makes it really easy. It's very user-friendly. That's the idea. I want to talk a little bit about AWS. So AWS is Amazon Web Services. And Amazon Web Services provides cloud infrastructure with zero upfront investment, low operating costs, and flexible, elastic capacity. That's the whole idea behind it. They want to make it easy for you to use, and you can do whatever you want with it, with the infrastructure. And I like this quote from Werner Vogels, who's one of the two guys that invented Amazon. He said, "Everything fails all the time." What does he mean by this? Well, he means that mistakes happen and things break, but with Amazon Web Services, you can design for failure. You can use IT automation, scripts, and development tools in order to automate your infrastructure so that if something breaks, it's automatically fixed and the resources are re-provisioned dynamically so that everything automates itself even if something is failing. It'll fix itself. You can think of, there's actually a thing that Netflix created called Chaos Monkey. And it's actually, so Netflix is on Amazon Web Services. It's one of the biggest clients of AWS. And Netflix created this thing, Chaos Monkey. The purpose of it is actually to try to destroy the Netflix cloud in a testing or in a staging environment. It messes with your security groups. It turns off servers. It does whatever it can. But everything is so automated with Netflix on the Amazon Web Services that it can fix itself. It automatically reprovisions the resources necessary. I want to talk about the 3 coolest AWS facts. So originally, the Amazon.com platform was overburdened by traffic during Black Friday and Christmas. On these 2 days, there's a lot of sales, and they just get hit by a lot of traffic. And they weren't even able to manage their own workload. So Amazon.com went down a few times, which led to loss of sales. Thus, Amazon Web Services was invented so that Amazon.com could scale elastically during the peak holiday season. But they also wanted to make this a service that other people could use. So it's an Amazon.com runs on AWS, but you can run your applications on AWS as well. So each day, AWS adds the equivalent server capacity to power Amazon when it's a global $5.2 billion enterprise. Every single day, it's adding data centers, it's adding servers, it's adding tons more capacity to meet demand. So I want to talk about a couple key concepts: elasticity and scalability. Elasticity is the ability to dynamically adapt to change to meet a variable workload, whereas scalability is the means to adjust in calculated amounts to accommodate growth. So the way I think about this is that scaling out is key to serving customer needs, and elasticity is where the savings occur. Now, I want to emphasize that an elastic and scalable architecture is critical to taking advantage of the cloud. That's how you make sure that you're able to serve the customers and make those savings. So I think that elasticity and scalability are really two keywords that even business people need to know when they're engaging a client. And because setting up that elastic and scalable architecture is a little bit tricky, but it grants great dividends in the long run. So that's where Slalom can bring a lot of value, is in creating that architecture to take advantage of the cloud. So here's a graph of capacity versus usage on AWS. So the idea is that the red line is the amount of compute power, the actual usage needed to meet customer demands, and it changes over time. So your on-demand capacity with AWS can change elastically to meet demands of your customers. So one way to do this is to always have the on-demand capacity be 15% greater than the actual usage. And then you kind of have time to shift and make adjustments as you have more or less demand. This leads to no customer dissatisfaction and no waste. At least that's the idea. How does this work? Well, pretty simply, there's the internet. Your customers, since the cloud is accessible via a website, they're using the internet to access your application, whether it's software as a service or infrastructure as a service. And then you have a thing called an elastic load balancer. This balances the load elastically. So let's say on the left-hand side that you have 2 medium servers, right? But then a bunch more customers come online and they all want to access your site. Well, then you can scale out dynamically with the elastic load balancer, automatically provisioning 2 more servers so that you can have your customers can hit all 4 servers, and there's no waste. Plus, everybody meets the requirements that they need. It can also scale back in. You can go from 4 servers down to 2. And the cool thing about the elastic load balancer, as I explained, is that it does it automatically. You don't have to have someone sitting there reviewing the amount of compute capacity that you need. It's able to do it, provision this automatically, which is going to be more efficient, save you time and resources. Here's an example of how to optimize by time of day. So let's say that in the traditional IT model, you would buy 13 servers, and they would be on all the time. But let's say you do a little bit of research and see that the peak of demand is between hours 7.5 and 19.5. So that 12-hour period has the highest demand, whereas before and after work, people aren't using the servers as much. So you could scale down during those time periods down to just 7 servers, and that would create a 25% savings. On the Sony Media Cloud Service project, we exceeded even this optimization. We had a thing called Operation Light Switch, which in the QA and stage environments would scale down all of our elastic compute capacity down to 0 at 8 p.m. and scale it back up at 6 a.m. So all of our developers from 6 a.m. to 8 p.m. could work and test and be as busy as possible. But when it's the end of the day, we would shut down all the services, and that just doing that created 40% savings. So here's a graph that kind of compares the traditional IT model with the cloud computing model. So the dotted lines are the traditional IT model where you have to buy servers in chunks, right? So the blue line shows a huge capital expenditure to try to guess how many servers you'll need for your application. Over here, you have a huge capital expenditure, but it's not quite used yet. You're still ramping up. But over here, you actually lose customers because you don't have enough servers yet. And it takes time to install more servers, set it all up, so that you can meet demand of your customers. Okay? But here, this is the actual demand in red, right? With automated elasticity using Amazon Web Services or another cloud platform, you can automatically provision, let's say 15% more compute power than you need at a given time. That way, you never have excess capacity, and you also don't lose customers. I want to talk a little bit about the services that Amazon provides. First, I want to talk about Amazon Simple Storage Service, Amazon S3. This is, let's say, infinite cloud storage with secure HTTP access. You're allowed to store any amount of data, anytime, anywhere. It's highly scalable, reliable, fast, and durable. You have 9 nines of durability and 4 nines of availability. It's pretty simple, and it works really well. Amazon Elastic Compute Cloud, Amazon EC2, is an infinite cloud computing resources. You can scale capacity automatically per your requirements. You can optimize elastically based on real-time demand. And you pay only for the resources that you actually use. For security, I have a metaphor that I want to give you. So, AWS security is a lot like a safety deposit box in a bank. So, you have your own key to the box, but the infrastructure of the bank is managed by the vendor, by the bank itself. AWS is a lot like that. They have what's called a shared responsibility security model. AWS provides the physical, network, and virtualization infrastructure. They also provide certifications like PCI for the payment card industry, HIPAA for the healthcare, and ITOR for the government. The customers are responsible for the application security and the account management. That's like customers responsible for keeping their own key to their own safety box. And you can encrypt your own data and manage your own security groups using a private cloud, which gives you a lot of power in controlling your own infrastructure within AWS. In terms of pricing, because many business people are going to ask, well, what does it cost? AWS S3 starts at 9.5 cents per gigabyte. AWS EC2 small instances are only 9 cents per hour. Now, we use a lot of EC2 small instances on the Sony Media Cloud project. The idea behind it is that they're short horizontally, but they can scale vertically. So if we have like a web server, right, we can use a small instance, and if we have a lot of traffic, we can use many small instances to meet demand. This works really well for us, so I recommend the small instance. Now, I want to point out that redundancy increases costs. So there's the idea of building a redundant infrastructure. There's different regions, for example, US West and US East, Australia, Singapore, Ireland. There's different regions where you can deploy your AWS infrastructure and services. And then there's different availability zones within each region. And there's the idea to have redundancy. For example, have your database, your primary be in one availability zone, while your backups are in other availability zones. Okay. Same with your compute capacity. You might have 3 compute servers in availability zones A, B, and C. Now this works really well and is a great feature of the cloud, but I do want to point out that redundancy does increase costs. If you have 3 servers in 3 availability zones, that'll be 3 times as much cost as 1 server in 1 availability zone. There are some great resources for estimating your cost. For example, the AWS EC2 cost spreadsheet and the AWS cost calculator. I do recommend the cost calculator. You can put in different numbers for all the different AWS services and come out with exactly how much it would cost. This could be very beneficial for a client who knows what they need to put in the cloud, but they don't yet know how much it could cost. You could give them a lot of value by just plugging in their numbers into the cost calculator. Getting started with AWS is really easy. AWS has a free usage tier. You get 5 gigabytes of free Amazon S3 storage, and there's even micro elastic compute instances that are free. This is an opportunity to test drive key AWS products. All you really need to do is just start using the services, and you can gain experience at the cloud at no charge. Just query aws.amazon.com/free to learn more and sign up. Why sell the cloud? Slalom can use the cloud to enhance customer value propositions, and many businesses and executives want to move to the cloud. That's it. I hope you enjoyed this tech talk and that you learned something about the business case for cloud computing. Thanks for joining. Feel free to email me. I'm Galen Pyle from the Portland office in Portland, Oregon. Thanks so much. Appreciate it. Bye.